Alright, so here's our domain range function, not a function video. A relation is just a relationship between inputs and outputs. So you think of it just as a set of ordered values. It can be an equation, or it can just be a set of ordered pairs. A function is a relation, but in this case, every input has only one output. So you can never have one input going to two different outputs. So you can never plug in an x and get two different y's. So this is an example of a mapping of a function. That's fine. If they don't line up in order, that's fine. If all inputs go to one output, that's fine, because you still have each input is only going to one output. So there's no duplicates. That's fine. And then if you have one input that goes to two different outputs, then that is not fine. That's not a function. So in domain, just think of that being the inputs, range is the outputs. You should think of inputs, and also notice that there's alphabetical order here. So D comes before R, I comes before O, X comes before Y. So alphabetical order helps you remember that. We're not going to be calling them Y values, though. We're going to be calling them f of x values. So you plug in an x, and then, whoops, shucks. You plug in an x, and then what you get is f of x is the output. So discrete, just think points or dots are not connected. For continuous, think connected lines or curves. The vertical lines test just says that if a vertical line touches your graph in more than one spot, then it's not a function. Alright, so continuous is like this shows. Take a second to pause and read that definition. Okay, so essentially it's just that if I pick any two values, there's an infinite number of values in between. So it's like a connected line. If I pick two values here, there are no values in between. So that's called discrete. Alright, so notation on domain and range. Now this is only for discrete functions, as in not connected or continuous functions. The domain is all the input values, so if we look at these points that we see here, the x values are -4, 1, and 0. Typically you write them from smallest to largest. And then the range values would be all the y values, or all the output values. So for this, is it a function? This is not a function, and this is not a function because that input of 2 has two different outputs. So if we were to draw the mapping, you'd see that the 2 input has two different outputs, which is not okay. This is also not okay for the same reason above. If we drew the mapping, 1 has two different outputs. This is certainly a function. It's okay that 5 and -2 go to the same number, because if you plug in a -2, you get an answer. If you plug in a 5, you get one answer, not double, not 2 or 3 or more. For the domain, we write them in order from least to greatest, and then range, I also write them in order from least to greatest. So the set notation, or the bracket notation like this, is used for discrete functions. For continuous functions, you're going to use brackets and parentheses, and that's going to be called interval notation. We'll be using that in pre-calc and for the duration of the year. So if we look at the domain and range of this, domain are all the x values. So domains go from here, from 8, and this dot right there says that 8 is included. That's why it's including 8. And then to here, up to 5 and including 5. That's why we use these kind, because the dots are solid. You go up to and including that final number. The range is the y values, and that goes from a lowest number of -9, and that's a solid dot, so we include -9, and then the highest is, well, you know, it's line's supposed to go. That's supposed to go at 8. And this circular dot like this shows that we don't actually get to 8. We get right up to it, but don't include it. So it uses one of those. That's called not inclusive. All right, so some quickies here. The domain is going to be from 0, and it actually touches 0. So 0 inclusive up to infinity. And we, by definition, can't actually get to infinity, so we always use the parentheses, non-inclusive, when we're using infinities. So clearly, this goes on forever, and the x's are going to get bigger and bigger and bigger forever, so that's why it's up to infinity. You're never going to get to an end. And the range, though it goes over more than it goes up, and it doesn't seem to be getting very high as it gets bigger, if we went out to infinity, it would eventually get higher. So technically the range is going to be, and it goes in the lower direction and upper direction, so it's going to be from negative infinity to positive infinity. So that's not a point of negative infinity, infinity. That is interval notation for the range of this function. The domain here, you obtain every x value. Nothing is discluded. So that's going to be all real numbers. And we use, oh, that looks real pretty, that symbol. And then the range is going to be all real numbers. For this one, we get up to and including 8, it appears. It looks like the circle has a radius of about 10. So the domain is from, actually, trick question. The domain and range doesn't make sense to ask in this one because it's technically not a function. So this does denote all the, so if we want to say all the x values that we have here, they're from 0 to 10, or maybe 11. Let's call it 0 to 11 inclusive, and this is from -2 to 9-ish, it looks like. But technically these are not functions because a vertical line will hit that more than once, so this is not a function. A vertical line will touch that graph more than once, so this is not a function. Pardon. All right, a couple more examples here. So this is a continuous function, at least on the domain, from x is 2 to x is -1. It's a continuous function, all connected, and you can see that this is a solid dot, so the lowest x value is -1, and we include that -1, and then the biggest x value is up to 2, but you can see that the graph is this blue graph. You can see that it's not actually including that last endpoint, so that means that it's up to 2 but not including it. And then for the range, it looks like that's kind of tough to tell. We're going to estimate here. On a test, you would certainly have obvious values given. We're going to go negative, and we include it, -2.8 up to, looks like maybe 3.5, but we don't actually include the 3.5 because it is one of these kind of dealies. All right, this is a square root graph shifted slightly to the right. So this does actually obtain this value. It should have been more clearly stated, but square root of 0 is 0, so you can get that point. So the domain goes from 1 on to infinity. So include the 1 and up to infinity. The range, though the range doesn't, the y values or the output values don't grow as quickly as the x values, it still eventually will get bigger and bigger and bigger and never stop getting bigger. So it's going to be from 0 to positive infinity for that one. Pardon. What are we doing here? All right, last little set of examples, a couple of quickies here. So again, this is another function. It doesn't look like it gets very high, but if you were to continue out infinitely, it would still get infinitely higher. It would never stop getting higher. So anytime I picked a point the point to the right of it would be a little higher. And if I pick that point, the point to the right of that would be a little higher. So it's always going to get higher and higher and higher. So that tells us that the range, the set of y values, is going to be in all real numbers, because it goes from negative infinity to positive infinity. So you can write all real numbers, or you can write negative infinity to infinity if you want to be a little fancier, get used to that notation. And again, the domain input values is also all reals. So for this funky little 1 over x plus 1 graph, this approaches but never actually achieves the value of -1. You cannot actually plug a -1 into that function. So the domain is going to be from negative infinity up to -1, but not including it, so we use that kind of bracket. And then from -1 up to positive infinity. So you can't actually get -1 on the domain, but you can get infinitely large or infinitely less than -1. And it's a similar argument for the range. The range never obtains 0 because there's an asymptote there, but you can go up infinitely or down infinitely. All values to positive infinity and negative infinity are obtained. So from negative infinity to 0, not including 0, not including 0 up to infinity. All right, enjoy the rest of your day.